Okay, hello everyone. I'm afraid that this week's video is pre-recorded, so we won't be on Jitsi the way we usually are after these sessions, but we will be completely back to normal next week. And we thought we'd take advantage of you not being able to criticize us for it to do something that's a little bit boring but really quite important, which is a question of time management in software development. So, time management in software development is very difficult in general. It's one of the key problems in successfully developing software, but it's very difficult to do in the most general case. Fortunately, if you're working on a sort of smallish personal project, or even most of the things that are a key, are what most academic developers work on, it's not that difficult, and there are just sort of a few rules to bear in mind. And the main things are that there are two sort of areas you want to look at, which is one, how do you assign tasks? How do you work out what tasks you do when? And second of all, what do you do when things aren't working quite as expected? So the first one is a fairly classic sort of problem that a lot of people working in science will have encountered in other environments, and you'll quite likely have seen something like this this Gantt chart that we have here. So Gantt charts are very simple. They show how time is used against tasks by different people. So this here is a fairly simple Gantt chart for a problem. It's a software development problem, and it shows how you use three developers, A, B, and C, to work on a problem. Now, in this case, I've done three developers, A, B, and C, but it can be one developer doing A, then B, then C. It can be one developer's time split into thirds. But in some senses, everything that I'm going to say here about multiple developers is even easier if you just apply it to one developer. So I'll talk in terms of 3 as a sort of fairly typical number for academic software development projects. So what this is showing is that initially we have 3 completely separate projects that don't depend on each other. Task 1, Task 2, and Task 3, and they all start at the same point, and you give them to different people. You give one to A, one to B, and one to C. And this is quite important because it means that you've been able to work out what happens first, i.e. you know that A, B, and C, you don't need A to be completed, 1, 2, and 3, you don't need 1 to be completed to do 2 or to do 3, and the other way around. So that's sort of the first trick in time management in software development, working out what bits of the development depend on what other bits. Now, fortunately, and the one thing that makes this one of the easier bits of time management in software development is the fact that this is almost exactly the same skill that you have to have for actually writing the software at all. The whole point is, you have to deal with imports or includes or uses depending on your language, but the idea is you say this bit depends on this bit, so this bit has to be written before this bit can use it. And it's much the same with the time management. The thing that's a major difference from the time management perspective is that you don't have to have actually implemented the things in detail. It's true, you cannot write, when you run a piece of software, you can't call a function without that function being there. It won't work. However, from the perspective of someone being able to write code that calls a function, all that they have to know is what the function's called, what it does, what assumptions it makes in doing that, and exactly what the signature for the function is, what parameters you pass it. And so long as that's been worked out in advance, you don't have to do anything cleverer than that, or anything more than that, perhaps I should say, in order to work on both pieces at once. So quite often that's where time management in software development starts. You start by working out what the interface is, where all the different tasks connect to each other, and what those connections look like, what the function calls are if you're doing object-oriented development, what objects are going to exist, what they're going to be called, and things like that. So that's really, in many senses, the key skill. You work out what the different bits of the program are going to be, how they interface with each other, and then you can start splitting them up and give them to different developers. Now this chart isn't a terribly complicated one, as I say. You first of all give task 1 to person A, then task 2 to person B, then task 3 to person C. And the thing that then is a limiting factor for A and B is simply when they've finished this task. So as soon as A finishes task 1, they move on to task 4. And as soon as B finishes task 2, they move on to task 5. C, on the other hand, has a bit more of a problem. And you can see here that C doesn't start task 6 until B has finished 5. So there is here a dependency, and this is the other part of the time management skill, which is working out where things genuinely depend. So, as I say, you can get around a lot of these dependencies simply by knowing the interfaces, but that isn't always possible. Imagine, for example, that one person is writing the new experimental algorithm to actually solve the problem of interest, and somebody else is supposed to be writing something that uses that to perform further calculations using it. In theory, they can write it without it being implemented, but in practice, there's only a certain amount of overlap there because you need the thing to actually work in order to check that you're writing your bit right and it's doing the right thing. Quite possibly, there's other problems, like you just don't know what the interface is going to be until you've finished implementing it. You should try and do design work to prevent that, but in general, in agile development, you just can't be sure. So it's not a problem. You don't usually have a complete week's gap of doing nothing here. You can do some work, but sometimes these real blockers occur. And what you want to do if you've got actually multiple developers is minimize them. In reality, there's almost always something someone can do, something that needs tidying, some documentation that needs working on, but you still want to avoid gaps like that in the Gantt chart. Now, in many senses, the simplest solution is what I've sort of shown here as a gradient, which is this task 5. So, person A is off doing their own work perfectly happily, but here for task 5, you say, oh, well, can B and C work together on this? Well, maybe they can, and if they can, that's great, and then they go off and do their own 6 and 7 tasks afterwards. But sometimes they just can't. Sometimes it's just not efficient to try and do that. Sometimes you don't really have two people with overlapping skill sets and things, so you can't always rely on that. But fortunately, in academic software development, it's actually much more common to see Gantt charts that look like this. So this one is, in a sense, some of the least interesting Gantt charts that there are around. And literally the only thing that stops the starting of the next task is a developer finishing the previous task. So C abuts C's work on 3, abuts C's work on 6, and similarly 1 and 4, 2, 5, and 7. So those are the nice simple ones, and that brings one in nicely to the question of how do you deal with it when things go wrong. So in these simple ones, in a sense, there's comparatively little problem with blockers. Because in that previous graph that I showed, if task 6 couldn't be started until task 5 finished, and something makes task 5 be delayed, well, that's really bad, and it's very difficult to work around. And there is no good answer. You can put more people on task 5, but quite often that can even make things worse because you have to bring the new people up to speed. If it's not just transcribing the Encyclopedia Britannica into a computer or something that someone can grasp immediately and can parallelize over many people, just putting more people into a task doesn't necessarily help. But that, and as I say, there really is just nothing you can do. If you find yourself in that situation where you're just waiting for somebody else to do their job, you've just got to try and find something else useful to the project that can be done with that developer. But there are another class of problems where you have things like this. Imagine that task 5 here is somehow optional. That task 5 wasn't something you promised to deliver, it's something that would be nice but isn't required. So For example, imagine, it's some sort of speed improvement. It'll make it 10% faster if you can make it work. If 10% faster is the difference between success and failure, well, you have to do it. But if 10% faster is just the difference between, you being able to go and get a cup of tea while it works, or going able to get a cup of tea and a biscuit, it probably doesn't make a tremendous amount of difference whether task 5 is there or not. So if task 2 here were to overrun, say, into week 4 or week 5, you might be better off just dropping task 5. And here in reality, you'd have some, if you're actually drawing this Gantt chart at a later diagram, you'd have some extra blocks here indicating that task 2 had overrun. One of the things that I really haven't mentioned is that some people would say you should always put, possible overruns into these Gantt charts if you draw them. And actually build those sort of possibilities for things to go wrong in. And if you're dealing with, really time-critical problems, then yeah, absolutely, that's the way to go. But fortunately, most academic software development projects are not truly time-critical. You're simply trying to make sure that everything that is absolutely crucial gets done by about the right time. There's usually a certain amount of slack in when that delivery time is, and there's usually a certain amount of slack on what the list of features are. So realistically, that's what the elements here are. I'll just quickly recap them. You want to do time management. You want to know what I'm going to do when. And if you want to be able to successfully deliver a piece of software broadly on the time scale you want, it's something you need to work out. Which means in turn you have to work out what the parts of the problem you're trying to work on are, and how they fit together, and in what order they fit together, and how you can do enough of them that allow, if you've got many people, how you can allow many people to work on the bits independently. If you don't have many people, then you have a bit more freedom, but on the other hand, you still realistically want to know what you're going to do in what order. And quite often there really is just sort of a logical order which you can go through that makes sense and allows you to test bits of the code as you go and make sure they all work together nicely. Finally, you have to remember that, to paraphrase German General Helmut von Moltke, no plan survives contact with the enemy. Whatever you plan, there is a very real chance it's not going to work quite the way you think it did. So you have to be prepared to be flexible, you have to be prepared to make changes, which may involve redrawing your chart as you go. It may involve dropping features that are not required for the success of the project. It may involve trying to get more developers on the project if it'll work like that and you have the opportunity to. But you have to have the opportunity, you have to build in the idea that certain amounts of flexibility are necessary in time management. So I'm going to, at that point, finish and say that next week we will be back live again, and we'll also be next week on Jitsi, and sorry that we can't be available this week.